Acceleration is a term that we use in our everyday lives, but in physics it has a special meaning. So in our everyday lives, we consider acceleration to be when you're speeding up. We say that you're accelerating. But in physics, acceleration is defined as the rate of change of velocity with respect to time. So that means an object has an acceleration anytime the velocity is changing. Now we know that velocity is kind of like a speed with direction. So in other words, an object is accelerating if its speed is changing, so it's speeding up or slowing down, or if the direction of its motion is changing. So that's a little bit different than what we use in our everyday lives, because usually we say accelerating means speeding up and decelerating means slowing down. But in physics class, we'll say that an object is accelerating whether it is speeding up or slowing down. So we'll quite often use those terms, speeding up and slowing down, to be clear what is actually happening to the motion. Now that phrase, the rate of change of velocity with respect to time, is actually going to help us write an equation for acceleration. Anytime we see change, we know that that actually has a mathematical meaning. So this is an equation for acceleration, and we use a lowercase a to represent acceleration. And it says the change in velocity, so we use that delta symbol to mean change, calculated using final minus initial. So this would be the final velocity minus the initial velocity. And anytime we see this rate of change, that means it's a fraction, and it says with respect to time, so we'll put a delta t in the denominator there. So we can find an object's acceleration by doing the change in its velocity divided by the time it took for that velocity to change. You'll also notice vector symbols on this equation, right here and right here. So that means acceleration is a vector. So it's really important that it has a direction. Every answer that you give with acceleration should have a direction, unless the question asks for the magnitude of your acceleration. And so if it says magnitude, we only care about the number. Magnitude is kind of a fancy way of saying absolute value. The last important thing to know about acceleration are its units. And we're going to rely on this equation for acceleration in order to come up with its units. So my equation says that acceleration is equal to the change in velocity over time. And we know velocity typically has units of meters per second, and time typically has units of seconds. Now, having a fraction within a fraction is never a great idea. So we're going to simplify that by writing it as meters per second times 1 over seconds. We learned in math class that that's the same thing as this fraction here. And so we can simplify this statement to say meters per second squared. And so meters per second squared is our standard unit for acceleration. And typically that's the unit that we want to give acceleration in, unless we're told otherwise, or unless the problem that we're working on or the scenario that we're working on has everything in a different unit. We will, of course, learn way more about acceleration as we learn more about this current model.